According to the triangle inequality theorem, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. And so we had an example over here where we had A, B, and C side lengths, and A and B added together to be greater than C, B and C added together to be greater than A, and A and C added together to be greater than B. Notice that it's not greater than or equal to. They always have to be, that sum has to be bigger than the last. So now it says, state if the three numbers can be the measures of sides of a triangle. We're going to add 10 plus 11, and we want to know, is that greater than 12? It is. We also could say, is 11 plus 12 greater than 10? It is. And 12 plus 10 is 22. Is that greater than 11? It is. And so are these possible? Yes. Now, we can do this for all three measurements, or we can just do it for the two shortest sides adding up to and being greater than the longest side. Because once we know that the two shortest sides are bigger than the longest side, it's always the other ones are all going to fall into place. So over here, I can take my two shortest sides, 5 and 5. 5 plus 5 is equal to 10, not greater than 10. It's not greater than 10. And so this is no. These sides can't make up a triangle. If we drew the 10, our long side, and then we drew our 5 and our 5, the 5 and 5 would collapse on that line. So these cannot be a triangle measurement. Same thing here. 2 plus 4 is not greater than 8. 2 plus 4 is 6. And so these would not form a triangle either. And that all comes back to that triangle inequality theorem. So down here, now we say a triangle has whole number side lengths. Two sides are given below. Determine the greatest possible measure of the third side and write your answer as an inequality. So now we're kind of extending this knowledge and saying, okay, well, we have 12 and 15. 12 plus 15 is equal to 27. So if x is the third side, x equals length of third side. We've got all these numbers in x. And they want to know the biggest that x can be. X has to be less than 27, because at 27, 12 and 15 can no longer be propped up. They're going to collapse down at 27. So x has to be less than 27 so that those two sides can stay propped up and not collapse here. And so in this case, our inequality is x is less than 27. The greatest whole number there would be 26. We also have 8 and 10. So again, if we let y equal the length of the third side, whenever we can, we want to define our variable. If we have y as our longest side, and we say 8 plus 10 is 18, at 18 is when those two sides will collapse. They can no longer be propped up. And so y has to be less than 18. So the biggest whole number it could be is 17. But it asks us to write our answer as an inequality, so I say y is less than 18. And so here we've talked through using the triangle inequality theorem to determine if two numbers or three numbers can be triangle measures, and writing inequalities to find the third possible measure. At this point in time, I would challenge you to try these next two on your own, and then we'll do the last two together. But I want you to try these next two on your own. See if you can write your own inequalities for the next two examples.